All right, so again here in section 6, that first, like section 6, part 1, we're just talking about what is a line of best fit. So there's a lot of times in the real world data that are not linear, but we have trends and we can take enough data from enough resources to see what's actually happening. And so we talked about, again, how to draw in a line of best fit. That line should represent the trend of what we're seeing, okay? We will practice actually drawing in lines of best fit next class, but to finish up today, what we want to look at would be how do we actually find the slope from a line of best fit, and how do we write an equation? Well, the good news is we've already done this, but some students look at something like this and they're like, oh my gosh, there's dots everywhere. There's some dots on perfect corners, there's some that are not. We're not gonna focus on the data, but we're gonna focus on the line that meets the data, right? And so from here, if we were gonna write a line of best fit, or if we wanted to find the slope from the line, we're gonna look for, again, perfect corners for the line that's there. So I can see at 0, I can know that's exactly 10. If I come over here to 3, not quite on a perfect corner, come over to 4, perfect corner, where the line is meeting the gray grid lines, okay? So from here, if I wanted to know the slope, the unit rate, okay? We're finding those perfect corners, so then I'm checking how much did I rise and run. So I'm gonna increase 5, 10, 15, running 1, 2, 3, 4. Okay? If I was to divide them, probably gonna get a decimal that's not very exact. Okay? So my advice for you here then is to leave it in fraction form. So if your rise and run when you get to Schoology is 7 over 5, or in this case 15 over 4, 3.75, that's not, like, that doesn't go on forever. It's kind of a clean looking decimal, but this would be our best option. We want to avoid writing decimals in equations. Okay, so anything that I'm talking about right now, you could be adding in the margins of your blue packet if you feel like this would be helpful for you right now. Okay, so I know that these examples aren't in there exactly per se. So then if we had a problem like this, our trend line, would you say it's positive or negative? It's a negative trend, okay? So I know my slope is going to be negative, okay? So again, we're gonna look for perfect corners. Sometimes, again, the perfect corners are the data with the line. I'm touching 1, 2, 3, 4 of the pieces of data. I don't think they're necessarily perfect corners, but I can see that this is a perfect corner for my line of best fit. And maybe all the way back up here at the start point where I hit the y-axis, okay? So we find those perfect corners. Our rise is how much? Can you see from where you are the scaling? 10, 20, 30, 40, 50. So these are going by tens. So my rise here is 10, 20, 30, 40. My run is 7. It's a little bit cut off down here and you can't see that. So again, 40 over 7 is not something that divides out nicely. We're gonna get comfortable with leaving that unit rate as a fraction. But what am I missing? The line is going downhill. So instead of 40 over 7, it's going to be negative 40 over 7. If the problem said write the equation, I then need one more thing, and what is that? Where does the graph start? Starting up at 60, 70, 80, 90. My equation here is 90 minus 40 over 7x. Right? So again, the content of writing equations from scatter plots is the same thing we've been doing. The graph is just a little bit more busy with lots of data being provided. The line of best fit is the trend.